Hi, my name is Divagar Kumar. Today we will discuss electrostatic chapter. This question is asked in Jee Advance in 2020 paper 2. In the given question it said that two non-conducting solid spheres of same mass and charge are suspended in air from a common point by two non-conducting massless string and same length. It means there is two scenario. One scenario, the solid sphere is suspended in air, and in second scenario the solid sphere immersed in liquid. Density of the liquid is given 800 kg per metric cube, and also its dielectric constant is 21. In both the situation it states that the angle of suspension is same in both the scenario, in air and in liquid, that is alpha. In solid sphere mass is same of both the sphere and also charge is same. In given question it says that. Now first of all we draw its free body diagram. In air it is solid sphere due to mass acting gravitational force downward due to gravity, that is mg, and due to a charge electrostatic force will be appear, that is Fe, and due to a string, in a string there is a tension, that is T. If we draw a vertical line, that is bisect the angle equally parts, this angle is alpha by 2 and also this angle is alpha by 2. So from the vertical we draw that angle is alpha by 2. If we break the tension in the two component, that is in horizontal component and in vertical component, the vertical component is t cos theta, and horizontal component is t sin theta. Sorry, there is no theta, that is alpha by 2. Here also alpha by 2. Electrostatic force will be balanced by tension horizontal component, and gravitational force is balanced by tension horizontal component, sorry, vertical component. So we write its equation. This equation is, we can write electrostatic force is equal to T sine alpha by 2 and gravitational force is equal to T cos alpha by 2. We can say this is equation 1 and this is equation 2. If we divide equation 1 upon equation 2, from here we can calculate the value of angle alpha. T sin alpha by 2 upon में t cos alpha by 2 is equal to electrostatic force upon में gravitational force. Tension will be cancelled. This quantity is equal to tan alpha by 2. So here tan alpha by 2 equals to Fe upon में mg. Now same condition we saw at second scenario. In air there is no buoyancy force, but in liquid on the sphere one extra force is acting, that's named buoyant force, and that is acting vertically upward. If we draw its FBD, vertically upward buoyant force, we denoted by FB, and it's due to mass vertically downward force mg, and electrostatic force same, that is Fe, and tension in the string we can say that it is T dash. Now here we break the tension in two component. One component along the Fe direction and second component along the horizontal vertical direction FB. Sorry, here wrong. Fe is not acting like that. It's acting toward outward. That is Fe. So here vertical component is, here also draw angle bisector. It is alpha by 2. So this angle is also alpha by 2. So T dash cos alpha by 2 is equal to, sorry, tension vertical component and buoyant force acting in the same direction, and both are equal to the gravitational force. So we can write its equation like that: T dash cos alpha by 2 plus FB equal to mg, and T dash sin alpha by 2 is equal to Fe. Now here we calculate buoyant force. Buoyant force, as we know that buoyant force is mass displaced by the body removed by the removed liquid, and its gravitational constant, sorry, gravitational gravity G, ml into G is equal to buoyant force. From here we can write it Fb is equal to ml into G. We can write ml also in format of mass density and volume. Mass density of liquid is given, that is we say that it's sigma into volume of liquid that is removed into G. We can also write volume in terms of a sphere, that is mass density of a sphere and volume of a sphere, sorry, volume of sphere, sigma into actual mass of the sphere upon mass density. It's assume that rho, here rho we can calculate into G. In simple term we write it sigma upon rho into mg. This is equal to buoyant force. If we write T dash cos of alpha by 2 plus Fb equal to mg, it is equation number 3, and T dash sine of alpha by 2 equal to Fe, it's equation number 4. In option it says that mass density of the sphere is 840 kg per metric cube. So here we can calculate the rho, mass density of a sphere. We can calculate it. There is condition: the angle is remains same in both the situation, in air and in liquid. So we can first calculate the angle. Tan alpha by 2 here in air is Fe upon mg, and similarly we can also calculate tan alpha by 2 in liquid. So we can divide equation 3 upon equation 4, sorry, equation 4 by equation 3. Divide the equation 3 by equation 4. T dash sin alpha by 2 upon T dash cos alpha by 2. Here plus Fb we take right hand side, that is mg minus Fb by 2. Fe electrostatic force upon mg minus Fb. From here T dash and T dash cancel out. So tan alpha by 2 is equal to Fe upon में mg minus Fb, and we calculate Fb is sigma upon में rho into mg. So we can write it also Fe upon में mg minus sigma by rho into mg. Here mg is in both the terms, so we can common out the mg. So we can write it Fe upon mg common 1 minus sigma by rho. From here tan alpha by 2 and tan alpha by 2, we compare both the quantity. Fe upon में mg is equal to Fe upon में mg into 1 minus sigma upon में rho. And also this is the this Fe is actually k 1 upon 4 pi epsilon naught into q square upon में r square. This is for the air, and for the liquid the Fe is differ, that is 1 by 4 pi epsilon naught, and due to medium its dielectric medium is epsilon r into q square upon r square. So here there will be only one variation, that is epsilon r. So we can write also Fe upon mg is equal to Fe by epsilon r upon mg into 1 minus sigma upon rho. So we can write it Fe से Fe cancel, mg also cancel out. One minus sigma upon rho into epsilon r is equal to 1. So 1 minus sigma upon rho is equal to 1 upon epsilon r. Here we simplify 1 minus mass density of liquid upon mass density of a sphere is equal to 1 upon epsilon r, that is given in the question. It's 21 dielectric constant, 1 upon 21. Now in the given question mass density of liquid is given 800 kg per metric cube. From here we can calculate easily mass density of the sphere, and from this answer and this we compare and then decide option A is correct or not. 1 minus 800 upon mass density of the sphere is equal to 1 upon 21. 1 upon 21, 1 minus 1 upon 21 is equal to 800 upon rho, and we can also write 21 minus 1, that is 20 upon 21. 20 upon 21 is equal to 800 upon rho, and from here rho is equal to 21 into 800 upon 20, that is 40. That is mass density of a sphere is 840 kg per metric cube. From here mass density of a sphere is 840 kg per metric cube, and we calculate also mass density of the sphere is 840 kg per metric cube. So option A is correct. Now the option B is, say the tension in the string holding the spheres remains unchanged. This option is incorrect. cause if we calculate also, it will be changed in air. If we see one sided, that is in air, only mg downward and fe outward. But in liquid, in case of liquid, here T dash, mg downward, electrostatic will be outward, and there is one force due to liquid, that is buoyant force, Fb. So here tension is not same. If we compare vertical component, then T dash cos alpha by 2 plus Fb is equal to mg, and in first case T cos alpha by 2 equal to mg. So here T dash cos alpha by 2 equals to mg minus Fb, and in first scenario T cos of alpha by 2 equal to mg. Here mg minus Fb or here mg. So remains unchanged. ये wrong होगा, ये ऑप्शन मेरा wrong होगा. And in option C it says that electrostatic force between the spheres is remains unchanged. That is correct. And D option is reduces. So option D is incorrect. Thank you.